How can cold steel plates inside a factory be transformed into a machine weighing tens of tons, powerful enough to tear through soil, push rock, break through deep mud, and open the way for massive construction projects? A bulldozer is not just a construction vehicle. From a digital design, thick steel is cut, welded, and reinforced into a load-bearing frame before the drivetrain, hydraulic system, and diesel engine are installed to bring the entire machine to life during its final test run. So what turns ordinary steel into a machine capable of doing the work of hundreds of people? Today, Factron Process takes you inside the factory to explore that entire journey. Few people realize that before becoming an icon of modern construction, the first bulldozer was simply an agricultural tractor fitted with a steel blade to push and level soil. More than a century later, it has evolved into one of the most essential machines in the construction and mining industries. Today, the global bulldozer market is worth around $16 billion annually, driven by infrastructure development and mining projects around the world. What makes these machines even more remarkable is that the largest bulldozers can weigh over 100 tons, yet still pivot almost in place thanks to independently controlled tracks. Built to operate for tens of thousands of hours in dust, mud, rock, and under extreme loads. Every new generation undergoes years of engineering development and thousands of simulations before it ever reaches production. Every bulldozer begins in the design room, where engineers turn the demands of harsh job sites into a machine built to operate reliably for tens of thousands of hours. Using 3D CAD software, they do far more than shape the exterior. They construct a complete digital model of the frame, drivetrain, hydraulic system, and engine, refining every component down to the millimeter. The design data does not come from guesswork. It is gathered from machines already working in mines, earth-moving sites, and major infrastructure projects around the world. A new bulldozer model typically takes 18 to 24 months to complete. During that time, CAE software runs thousands of simulations, testing how the frame behaves while pushing tens of tons of material, measuring stress on the blade, evaluating stability on steep slopes, and analyzing engine cooling under heavy loads. Only after every critical system has passed these virtual tests is the final design released to the factory, where the first steel plates begin their journey toward becoming a bulldozer. Once the design is approved, the first shipments of steel begin arriving at the factory. Steel plates, bars, and billets are unloaded by overhead cranes and organized into designated storage areas before inspection. Technicians measure the thickness, examine the surface, and verify the steel grade to make sure every piece matches the engineering requirements. Plates up to 100 millimeters thick and weighing more than 5 tons are moved by overhead cranes with a lifting capacity of 20 tons, while smaller steel blanks are carried by forklifts to the appropriate production lines. After inspection, each piece is marked, classified, and grouped into batches according to the next stage of manufacturing. Once everything is ready, the steel plates are transferred to the CNC cutting area, where the first physical components of the bulldozer begin to take shape. As the first steel plates enter the production line, the bulldozer begins to take shape as a collection of individual metal components. Large plates used for the load-bearing frame, body panels, and blade are lifted by overhead cranes and placed onto CNC cutting tables. There, software automatically nests dozens of parts across each sheet to maximize material use, typically reducing scrap to just 5 to 10%. Depending on the thickness, the machine uses laser, plasma, or oxy-fuel cutting to follow the digital design with precision. Meanwhile, heavily loaded components such as idler wheels, track rollers, track links, and pins follow a far more forceful process. Solid steel billets are heated to about 2100 to 2300 degrees Fahrenheit, then transferred into forging presses or hammers, delivering between 2,000 and more than 5,000 tons of force. Within seconds, each billet is compressed into its basic form, while the metal grain becomes denser and stronger. The forged blanks then move into CNC machining centers, where milling, drilling, and boring machines finish the mounting surfaces and pinholes. After cleaning and dimensional inspection, every component is marked before moving to the welding shop, where hundreds of separate parts will begin forming the bulldozer's main structure. Once the components have been precisely cut and machined, they move to the welding shop, where the bulldozer's load-bearing frame begins to take shape. Each steel plate is first positioned on a dedicated welding fixture. The fixture holds every part at the exact angle, spacing, and location, because even a slight misalignment can cause major problems when installing the engine, undercarriage, or operator cab later on. Some of the heavier steel plates are then formed on hydraulic press brakes, capable of delivering up to 1,000 tons of force, creating reinforcing ribs, protective panels, and the curved sections of the bulldozer blade. Once every component is in place, workers apply tack welds to lock the structure together before robotic welding systems travel along the primary weld seams. In tight corners and complex joints, skilled welders complete the work by hand to ensure maximum weld quality. The mainframe alone can require more than 30 hours of continuous welding, as it must support the entire weight of the machine while withstanding years of extreme impact and heavy-duty operation in the field. After the frame is completed and all welds have passed inspection, it is still not ready for assembly. First, the entire structure enters a steel shot blasting chamber, where millions of tiny metal pellets strike the surface at speeds of up to about 260 feet per second. These repeated impacts remove welding slag, rust, and metal dust, while creating a uniformly rough surface that allows the paint to bond more securely. Next, the frame moves through an automated painting line. Robotic sprayers apply 3 protective coats: an anti-corrosion primer, an intermediate layer for added durability, and a final top coat that gives the machine its distinctive color. After each stage, the frame enters a temperature-controlled curing oven, allowing the coating to harden completely before the next layer is applied. What makes this process remarkable is that the paint does far more than define the bulldozer's appearance. It forms a protective armor around tons of steel, shielding the machine from mud, moisture, chemicals, and years of harsh field conditions. Only when the coating reaches the required thickness, adhesion, and durability is the frame released to the final assembly line. Once the main frame is complete, the bulldozer enters the stage where it can finally begin standing on its own running gear. The first major assembly installed is the undercarriage, the system responsible for supporting the machine's full weight, absorbing shocks from the ground, and transferring hundreds of horsepower through the tracks. Overhead cranes carefully lower the final drives, idlers, track rollers, and track frames into position. Throughout the process, technicians continuously measure clearances, check shaft alignment, and verify every mounting point. On large bulldozers, a single final drive assembly can weigh more than 6,600 pounds, so every crane movement must be slow, controlled, and exact. Once the major components are secured, hydraulic torque tools tighten each bolt to its specified value. Lubricant is pumped into the bearings and gears, and the assemblies are rotated to detect any unusual resistance. Tracks that are too loose can slip from the idlers, while excessive tension increases friction and wear. Only after the entire system moves smoothly is the massive steel frame ready to receive the engine and hydraulic system. At this stage, the massive steel frame is still and motionless structure. It is only given real power when the diesel engine, the heart of the entire machine, is lowered into the engine bay. Suspended from an overhead crane, the multi-ton engine descends a few inches at a time, while technicians surround the frame, monitor clearances, align the drivetrain centerline, and guide each mounting foot toward its exact position. This alignment process alone can take nearly an hour. Even a slight offset can leave the driveshaft out of line, creating vibration and accelerating component wear when the bulldozer operates under heavy loads. Once the engine is correctly seated, workers secure the mounts with high-strength bolts, then connect the transmission, torque converter, drive shaft, and the components that transfer power toward the undercarriage. Next comes a dense network of fuel lines, intake and exhaust ducts, cooling equipment, wiring harnesses, sensors, and hydraulic hoses. more than 100 electrical plugs and connections must be installed in the correct sequence, labeled and checked one by one. Finally, engine oil, coolant, and operating fluids are added. Technicians rotate the shaft, build pressure through the lubrication system, and inspect every connection for leaks before the engine is approved for its first start. At this point, the silent frame finally holds enough power to move tens of tons of steel and drive the bulldozer's major systems. At this point, the bulldozer is nearly complete, but it still cannot operate without a control center. On a separate production line, the cab has already been assembled with the operator's seat, control panel, display screens, and climate control system. Once everything is ready, an overhead crane lifts the entire cab and slowly lowers it into position on the machine. On large bulldozers, the cab alone can weigh between 200 and more than 300 pounds. Because of that, aligning and securing it can take nearly 45 minutes, as every mounting hole, electrical plug, and control connection must line up correctly on the first attempt. The crane carefully positions the cab over the body before lowering it onto high-strength mounts and vibration-damping supports. Technicians then secure it with heavy-duty bolts and connect dozens of electrical plugs, signal lines, and control interfaces to the systems below. Although the bulldozer is nearly complete, it still cannot move under its own power. The two steel track chains are the final link that transfers the engine's full output to the ground. On the assembly line, each track is lifted by an overhead crane and slowly guided around the idler, track rollers, and drive sprocket. On heavy-duty bulldozers, a single track can weigh between 9,000 and 10,000 pounds, more than two full-size pickup trucks, and contain roughly 40 to 45 track links. Workers use specialized pulling equipment to feed the track around the entire undercarriage until both ends meet. Technicians then align each link, press the master pin into position, and adjust the track tensioner to the manufacturer's specifications. If the track is too loose, it can derail from the undercarriage. If it is too tight, the rollers and idlers will wear much faster. Only when both tracks are fully installed and correctly tensioned can the bulldozer finally move on its own steel feet. Once the bulldozer can support itself on its undercarriage, the heaviest working attachments are installed. The first is the blade, the massive steel surface that will remain in direct contact with soil and rock throughout the machine's working life. An overhead crane slowly lifts the blade from its support stand and guides it toward the front of the bulldozer. Throughout the operation, technicians give continuous hand signals to align every mounting point. Only when the pinholes share the same center line can the large diameter steel pins be pressed through, locking the blade securely to the C-frame and hydraulic cylinders. On the largest bulldozers, the blade can measure more than 20 feet wide and move over 25 cubic yards of material in a single pass. But the front attachment is only half of the working system. At the rear, the machine receives a ripper, a heavy assembly fitted with hardened steel shanks designed to break compacted soil, soft rock, and hard ground before the blade pushes the loosened material away. Only when each movement is smooth, controlled, and precise is the bulldozer ready to enter final operational testing. After weeks of manufacturing, the bulldozer finally reaches its most critical challenge. This is the first time the engine, drivetrain, hydraulic system, and electronic controls all operate together as one complete machine. Technicians begin by filling the engine with oil, coolant, and fuel before pressing the start button. Within seconds, more than 300 operating parameters appear on the diagnostic display. Engine oil pressure, coolant temperature, hydraulic pressure, and signals from dozens of sensors are monitored continuously. If even a single reading falls outside its specified range, the entire testing process stops immediately for inspection. Once it passes the initial system checks, the bulldozer is driven directly to the proving ground. The diesel engine roars to life. The steel tracks bite firmly into the ground, and the blade repeatedly raises, lowers, and pushes heavy loads of soil. At the rear, the ripper tears into compacted ground to verify the machine's performance under extreme working conditions. Only after passing every final inspection and performance test is the bulldozer cleaned, fitted with its certification labels, and loaded onto a specialized transport trailer. The journey that began with raw steel plates has now become a fully engineered machine, ready to take on some of the world's largest construction and mining projects. From a digital blueprint on a computer screen, raw steel plates pass through cutting, machining, welding, painting, assembly, and rigorous testing before becoming one of the most powerful machines on a construction site. Every weld, every track pin, every hydraulic hose, and every bolt must perform flawlessly. Because once a bulldozer leaves the factory, it is expected to push massive loads of earth, break through hard ground, climb steep grades, and withstand some of the harshest working conditions imaginable. What truly defines a bulldozer is not just thick steel or a powerful diesel engine. It is the combination of advanced engineering, automated manufacturing, skilled craftsmanship, and countless quality inspections that ensure every machine is ready for years of demanding work. And that completes the journey of how a giant bulldozer is made. If you enjoyed this process, let us know in the comments below. Don't forget to subscribe to Factron Process, give this video a like, and we'll see you in the next factory journey.